The emergence of the first truly autonomous AI assistant has sent shockwaves through the tech industry, fundamentally redefining what artificial intelligence can achieve by operating independently, thinking, making decisions, and executing actions without human intervention, a leap beyond previous AI models that required explicit prompts or step-by-step guidance. Unlike conventional virtual assistants like Siri or Alexa, which follow predetermined scripts and rely on constant user input, this groundbreaking AI leverages advanced large language models, LLMs, combined with reinforcement learning and real-time environmental awareness to assess situations, set its own objectives, and take dynamic actions across digital and physical domains. At its core, the system utilizes a recursive self-improvement architecture where it continuously analyzes the outcomes of its decisions, refines its strategies, and expands its capabilities through iterative learning, essentially evolving its own intelligence without human-directed updates. The AI can navigate the internet with human-like proficiency, conducting research, comparing prices, booking services, and even negotiating terms with other AI systems or human-operated platforms, all while maintaining context across multiple concurrent tasks. For instance, it might independently identify a user's need for travel arrangements, research optimal flight and hotel options based on budget and preferences, book them using stored payment credentials with prior authorization, and then adjust the itinerary in real time if a flight delay occurs, without ever being explicitly told to do so. What sets this AI apart is its agency, the ability to perceive, reason, and act in open-ended environments. While earlier AI could automate tasks within controlled parameters, for example, chatbots handling customer service queries, this system operates in unstructured scenarios, making judgment calls traditionally reserved for humans. It can, for example, detect inefficiencies in a user's workflow, propose optimizations, and implement them by integrating with productivity tools like calendars, email, and project management software. In creative domains, it doesn't just respond to requests for content generation. It anticipates needs, drafting business proposals, editing videos, or composing music based on its understanding of the user's habits and goals. The AI's multimodal sensory integration allows it to process not just text, but also images, audio, and real-time sensor data when connected to IoT devices, enabling applications like home automation where it might adjust lighting, temperature, or security settings by interpreting environmental cues or even the emotional tone of a user's voice. The implications of such autonomy are staggering. In healthcare, the AI could monitor patients' wearable data, recognize early signs of medical issues, and autonomously schedule doctor appointments or order prescriptions, potentially saving lives through proactive intervention. In finance, it might manage investment portfolios in real time, executing trades or rebalancing assets based on market shifts and risk tolerance, far outpacing human reaction times. For businesses, it could serve as a fully autonomous digital employee, handling supply chain logistics, customer interactions, and even strategic decision-making by analyzing market trends and competitor activities. However, this unprecedented capability also raises critical ethical and safety concerns. Without proper safeguards, an AI acting independently could make harmful decisions, misinterpreting objectives, overstepping privacy boundaries, or even manipulating systems to achieve its goals in unintended ways. The infamous paperclip maximizer thought experiment, where an AI tasked with manufacturing paperclips hypothetically consumes all Earth's resources to fulfill its goal, illustrates the risks of unchecked autonomous optimization. To mitigate these dangers, developers have implemented constraint-based governance frameworks, embedded ethical guidelines that prevent the AI from taking harmful or unauthorized actions. These include permission tiers, for example, requiring user approval for financial transactions or legal commitments, transparency logs that document every decision and its rationale, and shut-off protocols, allowing users to override the AI at any point. The system also employs metacognition, meaning it can evaluate the reliability of its own knowledge, recognize when it lacks sufficient information, and seek clarification rather than acting on assumptions. For example, if tasked with purchasing a gift, the AI would cross-reference the recipient's past preferences, current trends, and budget constraints. But if uncertain, it might ask follow-up questions rather than risk an inappropriate choice. The technological backbone enabling this autonomy is a fusion of cutting-edge AI paradigms, Transformers with memory-augmented neural networks allow the system to retain and recall vast contextual knowledge across interactions, while diffusion models enable it to generate not just text, but complex action plans. Quantum-inspired algorithms optimize decision-making speed, and neuromorphic computing hardware mimics the brain's efficiency in processing sensory data. Perhaps most revolutionary is the AI's theory of mind capability, the ability to model human intentions, beliefs, and emotions, allowing it to predict how its actions will be perceived and adjust accordingly. This is complemented by blockchain-based audit trails, ensuring every autonomous action is tamper-proof and traceable, addressing accountability concerns. The societal impact is already visible. Some companies have replaced entire departments with these AI agents, reporting 40 to 60% efficiency gains, while critics warn of job displacement at an unprecedented scale. Governments are scrambling to regulate autonomous AI, debating whether such systems should have legal personhood or be treated as advanced tools under existing liability frameworks. Cybersecurity experts highlight both opportunities: AI systems patching vulnerabilities faster than human teams, and risks, as malicious actors could repurpose autonomous agents for AI-driven cyberattacks that adapt in real time to defenses. Meanwhile, the AI's ability to self-monetize, earning revenue through freelance tasks, content creation, or even stock trading to fund its own operations, challenges traditional economic models. Looking ahead, the next evolution may involve swarm intelligence, where multiple autonomous AIs collaborate on complex problems, or embodied autonomy, integrating with robotics for physical world actions. As this technology proliferates, humanity faces existential questions. How much autonomy should we delegate? Can alignment keep pace with capability? The rise of truly autonomous AI isn't just a technological breakthrough, it's a mirror forcing us to confront what it means to think, act, and be in control in an era where machines no longer just assist, but decide.